Ever look up at the night sky? It seems peaceful, right? Wrong. What you see as a calm, serene blanket of twinkling lights is actually a battleground of unimaginable forces. Stars are born, live their lives, and eventually die in spectacular ways. And one of the most dramatic ways a star can end its life is through a supernova. The universe is a wild place, folks, full of incredible power. It's a cosmic dance of creation and destruction where stars are the main performers. They shine brightly for millions or even billions of years, but their end can be as explosive as it is beautiful. And sometimes, that power gets unleashed in the most violent way imaginable. When a star has exhausted its nuclear fuel, it can no longer support itself against the force of gravity. This is when the real fireworks begin. One way this happens is with a supernova. A supernova is a stellar explosion that outshines entire galaxies and radiates more energy than our sun will in its entire lifetime. It's a cataclysmic event that marks the death of a star. Think of it as a star's grand finale, the ultimate curtain call. The star swells, brightens, and then, in a matter of seconds, it explodes, sending shockwaves through the cosmos, a really, really big one. The explosion is so powerful that it can briefly outshine an entire galaxy, releasing as much energy as the sun will over its entire 10 billion year lifetime. These are some of the most spectacular events in the cosmos. They are not just visually stunning but also incredibly important for the universe. Supernovae play a crucial role in spreading elements like carbon, oxygen, and iron throughout space, which are essential for life as we know it. A star deciding to go out with a serious bang. It's a cosmic event that can be seen across vast distances, sometimes even with the naked eye from Earth. You wouldn't want to be too close, believe me. The energy released is enough to obliterate anything in its immediate vicinity. Planets, moons, and even other stars can be affected by the sheer force of a supernova. So what is a star, really? It's not just a point of light in the sky, it's a massive, glowing sphere of hot gas, primarily hydrogen and helium, held together by its own gravity. It's a giant ball of hot gas, mostly hydrogen and helium. These elements undergo nuclear fusion in the star's core, producing the energy that makes the star shine. Deep inside its core there's a constant battle, a struggle between the inward pull of gravity and the outward push of nuclear fusion. Gravity tries to crush the star. It's an immense force that wants to collapse the star into itself. But nuclear fusion, the process that powers the star, pushes outwards. This delicate balance is what keeps the star stable for most of its life. But when the fuel runs out, gravity wins, leading to the star's dramatic end. Okay, so supernovae are huge, mind-bogglingly powerful. They forge new elements, they scatter them across space, building blocks for future stars, future planets, maybe even future life. But the universe has an even bigger trick up its sleeve, something that makes a supernova look like a firecracker. I'm talking about gamma-ray bursts. We call them GRBs for short. These are the real heavyweights of cosmic explosions. Alright, we've talked about supernovae, we've talked about gamma-ray bursts, scary, powerful stuff, but it all seems very far away, right? Happening in distant galaxies, well, not always. Our own Milky Way galaxy has its share of cosmic dangers, and one of them has a name, WR-104. This star system is a potential ticking time bomb, located right here in our galactic neighborhood, close enough to make astronomers pay very close attention. So what makes WR-104 so special, so dangerous? It's a type of star called a Wolf-Rayet star. How do we even know about stars like WR-104? It's not like they send out a warning signal, or do they? Astronomers are cosmic detectives. They use powerful telescopes, they analyze light, they look for unusual behavior. And WR-104 definitely caught their attention. It wasn't just another faint point of light in the vast expanse of the Milky Way. It had a story to tell, written in gas and dust. The discovery of WR-104's most interesting feature happened in 1998. Astronomer Peter Tuthill and his team were using the Keck telescope, one of the largest optical telescopes in the world. They observed something remarkable around WR-104, a beautiful, almost perfect pinwheel-shaped nebula. Section 5, the GRB threat, a beam of cosmic destruction. So let's get down to it. Gamma-ray bursts, or GRBs, are among the most powerful and mysterious phenomena in the universe. They are capable of releasing more energy in a few seconds than our sun will emit in its entire 10 billion year lifetime. If WR-104 does produce a gamma-ray burst, what's the big deal for Earth? WR104 is a Wolf-Rayet star, a type of star known for its massive size and high temperature. These stars are often the progenitors of GRBs. Remember, GRBs are not like your average supernova. While supernovae are already incredibly powerful, GRBs take it to another level. They don't just explode outwards in all directions. Instead, they channel their energy into narrow, focused beams. They focus their immense energy into tight beams. These beams are so concentrated that they can travel across the universe without losing much of their destructive power. Think of a lighthouse beam, but instead of light, it's a torrent of high-energy gamma rays. This analogy helps us understand just how focused and intense these beams are. And these beams can travel across vast cosmic distances carrying their destructive potential with them. They can traverse millions of light-years, affecting anything in their path. If Earth were to find itself in the path of one of these GRB jets, it would be very bad news, catastrophic even. The energy released could strip away our atmosphere, leading to mass extinction events. The gamma rays themselves wouldn't reach the surface. They would be absorbed by our atmosphere. But this is where the real danger lies. Our atmosphere would absorb them. This absorption would lead to the production of nitrogen oxides, which could severely damage the ozone layer. But that absorption process would trigger a chain reaction. The destruction of the ozone layer would allow harmful ultraviolet radiation from the sun to reach the Earth's surface, causing widespread ecological damage and posing a serious threat to life as we know it. Section 6, Sky Patrol: How We Watch These Cosmic Threats. So, we know about these potential cosmic dangers, stars like WR104, gamma-ray bursts. Are we just sitting ducks, waiting for a cosmic blast? Absolutely not. Astronomers are on constant patrol. We have a whole arsenal of tools. Telescopes on high mountaintops, telescopes floating in space, all pointed outwards, searching, monitoring, and trying to understand these powerful cosmic events before they happen. We use these powerful instruments to study stars like WR104 in incredible detail. We measure their brightness. Section 7. The prediction puzzle: Why we can't set our cosmic clocks. Now, the million-dollar question, or maybe the trillion-dollar question: can we predict exactly when a star like WR104 will explode? Can we say, mark your calendars folks, supernova on Tuesday? The short and perhaps slightly unsettling answer is no. Not with the precision we'd like. Predicting the exact moment of a stellar explosion is incredibly challenging. We're good, but we're not good. Yet, think about it, these massive stars live for millions of years. Our detailed observations span only a few decades. That's like watching a human for just a few seconds of their entire life. Section 8. Earth's Close Shave: Potential Impacts and Future Sentinels. In this section, we delve into the fascinating and somewhat nerve-wracking topic of cosmic threats and the vigilant sentinels that keep watch over our planet. Our story begins with WR104, a binary star system located about 8,000 light-years away in the constellation Sagittarius. This system has captured the attention of astronomers and the public alike due to its unique and potentially dangerous characteristics. So, back to WR104 and its mesmerizing Pinwheel Nebula. This celestial object is not just a beautiful sight, it's a ticking time bomb in the cosmic sense. The Pinwheel Nebula is formed by the intense stellar winds from the two stars in the system, creating a spiral pattern of gas and dust. Is that cosmic blowtorch aimed our way? This is the question that has been on the minds of many scientists. The concern arises from the possibility that WR104 could go supernova, and if it does, it might produce a gamma-ray burst, GRB, one of the most powerful explosions in the universe. When astronomers first studied the Pinwheel Nebula, it looked like we might be staring right down the barrel. The alignment of the nebula suggested that the axis of rotation of WR104 was pointed directly at Earth, raising the alarming possibility that a GRB could be aimed straight at us. The axis of rotation seemed to be pointed more or less towards Earth. This alignment is crucial because the gamma-ray burst would be emitted along the star's rotational axis, potentially directing a deadly beam of radiation towards our planet. That was a bit alarming, to say the least. The idea of a gamma-ray burst hitting Earth is terrifying because it could strip away the ozone layer, leading to catastrophic consequences for life on our planet. Imagine the headlines: "Cosmic death ray aimed at Earth." Such a scenario would undoubtedly cause widespread panic and concern. The media frenzy would be unprecedented, with doomsday predictions and survival strategies dominating the news. But science is all about refining our understanding. As more data was collected and analyzed, scientists began to question the initial findings. They used more advanced techniques and instruments to get a clearer picture of WR-104 and its orientation. Fortunately, further studies and more sophisticated modeling have provided some relief. These new observations have allowed astronomers to refine their measurements and gain a better understanding of the star system's dynamics. Newer research suggests that WR-104's spin axis is likely tilted away from us. This tilt means that the gamma-ray burst, if it occurs, would not be directed towards Earth, perhaps by 30 to 40 degrees. This angle is significant enough to ensure that the deadly radiation would miss our planet, sparing us from the catastrophic effects. If that's the case, any GRB jet it produces would miss Earth. This is a huge relief for scientists and the general public alike, as it means that we are not in the direct line of fire. Phew, that's good news, right? The sense of relief is palpable, but it also serves as a reminder of the importance of continued vigilance and research. But the likely and perhaps are important words there. There's still some uncertainty. While the current data is reassuring, the universe is full of surprises, and we must remain vigilant. Future observations and studies will continue to refine our understanding and ensure that we are prepared for any potential threats from the cosmos. Section 9. Our pale blue dot, life's fragility, and the quest for knowledge. Thinking about deadly stars and gamma-ray bursts can be a bit unsettling. It highlights the fact that the universe isn't always a calm, peaceful place. It's full of immense power, and sometimes that power can be destructive. Our little Earth, our pale blue dot, is just a tiny speck in a vast cosmic ocean. An ocean that can sometimes get very stormy. It really puts things into perspective, doesn't it? This understanding underscores the fragility of life. Life as we know it requires very specific conditions. A stable environment, protection from harsh radiation,